Okay, welcome back. We're going to finish up our lesson today for our first week of math with a lesson on unit conversion by dimensional analysis. So far in this lesson we've been talking about basic calculator skills, reviewing how to follow different number patterns and get the correct answer on your particular calculator. And we've talked about positive and negative numbers, adding, multiplying, dividing, subtracting. And I've also introduced units a little bit. We talked a little bit about how if we have something like weeks and days, so if we have 3 weeks and 5 days and we want to add those together, that in order to do that we have to get to some base unit before we can combine those values. So we're going to look a little bit more in detail about how to get to that base unit and combine those values in this last lesson for today. So make sure you're with me here in the textbook. I'm on page 28 in chapter 2 of our basic math using whole numbers. Yeah, and good question. So go ahead and if you have any questions about as I'm going through this, go ahead and send them to me on the Q&A for a private question, or if it's something that is more public, you can put that on the chat and we'll respond to that and get your questions answered. So that question was just about these weeks and days, and sort of just reviewing how we talked about it before we started talking about dimensional analysis. We talked about wanting to figure out what base unit we wanted to convert something to, and what we used last time was we talked about using days. So instead of having 3 weeks, we wanted to figure out how many days that was. And when we talked about that, we all could agree that there were 7 days in a week. So when we did that, we just kind of came up with 3 weeks is equal to 21 days, and then we had the 5 days, so that when we added them together we got the 26 days. And so that's a really nice simple way to combine things that don't have the same units, decide what your base unit's going to be. In this case I chose days, and convert everything to days. Sometimes it's not going to be so easy. Sometimes we're going to have things like feet that we have to convert to miles, and we might not know that conversion, or we'll have something like feet per second and we need to convert that to miles per hour. So we'll have to do a couple extra steps. And when we do that, there's a method called dimensional analysis, and that method's going to be a way, a kind of a pattern or a recipe to go through these steps and to figure this out kind of in a methodical way. So let's take a look at the example that's in your textbook. Convert 36 inches to feet. So in this case, we want to get this inches. This time we're going to use feet as our base unit. Now, I see some of you are already sending me the answer to this in the chat and the Q&A, and that's great. So you already know this kind of off the top of your head. It's a simple example to start with, but we'll think about kind of a method that we can use for this simple example that we can then use for more complicated instances. And that's kind of a good thing about math, is when we can make it into something simpler and we have something complicated, that's a good way to solve our problem. So let's take a look at this one. We're going to write the original number with the units in fraction form. So even here I just have inches. My inches are not in fraction form. It's not feet per second or miles per hour. It's just inches. But getting into this habit of writing the units in a fraction form is a good idea. And remember, anytime we don't have a denominator, we can just put it over 1, because that's the same thing as not having a denominator at all. All right, so that's my first step, is to write the original number with the units in fraction form. All right, number 2, I'm going to multiply by a fraction with the unit you want to convert to in the numerator, the top unit, and the unit you want to cancel in the denominator, the bottom unit. And then I'm also going to use an equality relationship here. Okay, so let's take a look at what's actually happening here. Here's my 36 inches over 1, right, that I got from my number 1. here's my equality. So this, I'll call this my original. Okay, here's my second thing. I'm going to call this my equality relationship. Because I do know that 1 foot is equal to 12 inches. We also see it written like this. I would call that kind of in a horizontal format. But remember, we can also write this in a vertical format. If I wanted to rewrite this expression as a fraction, I could divide each side. Let me rewrite it here. 12 inches equals 1 foot. I could divide each side by 12 inches. I'll do like they do and abbreviate inches, IN. Okay, and then I know when I divide something on the top by something on the bottom, so I'm dividing the same by the same, I get 1. We talked about that right before this. So this would become 1, and 1 is equal to 1 foot over 12 inches, which is what I have here in my equality relationship. So writing it like that as a fraction is just a different format. I might call that a vertical format as opposed to this equality in a horizontal format. But it's going to be nice to have that in that vertical format, in that I'm going to be able then to do this fraction multiplication, which we talked about, and do some canceling to get my correct units. Okay, so essentially what I have here with my original and my equality is a fraction multiplication problem. And we talked about that before, that when I'm doing fraction multiplication, I can just multiply straight across for the numerator and then multiply straight across with the denominator. And here I've got my 36 times 1, so that's just 36. And then I have inches times feet. So I'll put my inches here and we put feet here. And then I have 1 times 12, well that's 12. And then in the denominator I just have inches. So that goes here, inches. Okay, and then when I look at this expression, I can see right away 36 divided by 12, well that's the same as 3. Okay, so that's that part. That's my constant part, my number part. Now let's take a look at my units. I have inches divided by inches. Just like I had here, when I have that same value in numerator and denominator, I can cancel those off. Okay, so that gives me just 3 feet in the end there, and that's what I'm left with. So that's one way to think about our dimensional analysis. We have a note here that inches over inches cancel, giving the required units of feet. So you have something that you start with, that's your original. You're going to multiply it by some equal relationship and making sure that you're going to cancel out what you don't want and be left with what you do want. So that's kind of our start here to the unit conversion by dimensional analysis. And we're going to do a couple more problems here. We're going to get a little bit more complicated here and convert miles per hour to feet per second, and see if we can use that same method to do that conversion. Okay, so before we start on that, let's try one. Why don't you all try one of this first type and send that in to me. So I'm going to write this down here. I want you to try this one, and you can just send me in the answer and send it to the Q&A. Let's go ahead and convert 5 miles to feet. And I'm going to tell you here about the equality that 1 mile equals 5280 feet. Okay, so using what we just did in this first example, go ahead and convert 5 miles to feet. Send me that answer in the Q&A section, and then we'll go over how to do that and move on here to the next step where we're going to convert miles per hour to feet per second.